follow along and fill in your notes with me. Okay, so let's start with multiplying rational expressions. So then we're going to start with this simple example with just basic fractions. So we have 4 over 15 times 10 over 12. So I know you know how to multiply fractions. You're just multiplying straight across the top and straight across the bottom, okay? What I'm going to show you is a way to do this with just simplifying the factors. So if we factor these two fractions out first, I'm going to start with the 4. So 4 would become 2 times 2, and 15 would become 3 times 5. Okay, so I've just factored the first fraction there, and then 10 over 12, that's going to factor to 2 times 5, and 12, which is 3 times 4, or in other words, 3 times 2 times 2. So now what I can do is I can just cancel off any factors that are common on the top and bottom. So 2 and 2 can cancel off. Another 2 and 2 can cancel off. The 5s and the 5s can cancel off. And let's see what we're left with. 2 over 3 times 3, which is 2 over 9. Okay, so multiplying 4 over 15 times 10 over 12 gives us 2 over 9. And I did that through just canceling off any common factors that we have. Okay, so we're going to use this as an analogy for when we have actually rational expressions with polynomials. Okay, so we'll go to the next slide. So let's look at this rational expression here. We're going to multiply these two. So first, what we want to do is factor each of the terms that we have in our fractions here. So x plus 5, we can't do anything with that. X squared plus 16, that's a difference of squares. Okay, and 2x plus 8, that's a GCF. And 2x squared minus 50 is another GCF. And we're going to see what that leaves behind later. Okay, so let's go through and factor all of that. So we have x plus 5, can't do anything. X squared minus 16 is a difference of squares, and that becomes x plus 4, x minus 4. Okay, so that's our first fraction. Our second one here, 2x plus 8. We common factor out a 2, so that leaves us with 2x plus 4. And at the bottom, 2x squared minus 25. Pulled out a 2. Okay? So let's have a look at what we're left with here. We see that there's a common x plus 4, and an x plus 4 I can cancel off, as well as a 2 and a 2 I can cancel off. But I'm also seeing that we have another difference of squares. Okay, so let's collect what we have. So on the top, we just have an x plus 5. Okay, we're still having the x minus 4 at the bottom, and the x squared minus 25 will factor into x plus 5, x minus 5 because of difference of squares. And if we see what we have there, we can cancel off the x plus 5, x plus 5, and we're left with 1 over x minus 4 times x minus 5. Okay, and that's your final answer for the multiplication. So don't forget, we also need to do our restrictions. So our restrictions are going to come from any of our denominators. Okay, so we have denominators here, and we have a denominator here, but that turned into those two factors of x plus 5, x minus 5, so that's going to be easier to tell what our restrictions are. So if we look from this group, we have that x cannot equal -4 or +4. And if we look from this group, we can see that x cannot equal 5 or -5. Okay, so you have 4 restrictions there. Okay, so the final answer is 1 over x minus 4 times x minus 5. And then our restrictions, we have 4 restrictions, -4, 4, 5, and -5. Okay? All right, so let's look at the next example. Okay, so we're going to be factoring first. So let's identify the factoring here. We're multiplying these two fractions together. Here, 10x minus 15, we have a GCF. Okay? And sorry, there should be an x in the denominator there. And that's also a GCF. Up here, x squared plus 2x minus 15 is a simple trinomial. And 4x squared minus 9 is a difference of squares. So 4 different types of factoring going on here. So let's go ahead and factor. So we've got 10x plus 15. I can pull out a 5. So that's going to be 2x plus 3 over, with a 10x plus 50, I can pull out a 10. And I'm left with x plus 5. Okay? And I'm multiplying all of this by, let's do a simple trinomial there. We've got x squared plus 2x minus 15. Let's do a little bit of side work. I'm going to go over here to do some side work. So we need two numbers which add to give us the middle number b, which is 2. And we have to multiply to give us c, which is negative 15. And those two numbers, if you think about them, are 5 and negative 3. 5 and negative 3. So I can go through and do my simple trinomial factoring. X plus 5, x minus 3. Okay? Over, we have now a difference of squares. 4x squared is a perfect square, 9 is a perfect square. So I'm just going to put in my square roots. So there's 2x here plus 3 and 2x minus 3. Okay, you're just taking the square roots of the first term, which is 4x squared, and the square root of the last term, which is 9. Okay? All right, so now, having a look at what we've got here, we can just start slashing. So let's look for some common factors. We have 2x plus 3 and 2x plus 3. That goes. We have x plus 5, that goes. And we also have 5 and 10, which can reduce. Okay, 5 over 10 can reduce down to 1/2. Okay, so I can have 1 over 2 for my 5 over 10. I'm left with an x minus 3 on the top, and I'm left with a 2x minus 3 at the bottom. Okay, and I don't really need to write that one, so I'm just going to write x minus 3 over 2x minus 3. Okay, and that's the final answer for the multiplication of those two fractions up there. Okay, now we need our restrictions. Again, we have to look from our denominators. And so here's a good place to look at our restrictions. So from this one here, I can see that x cannot equal negative 5. All right. And with these two, these ones are a little bit trickier. If you can't tell what those are straight off the bat, we can do a little bit of algebra. Okay, so I know that 2x plus 3, my first factor right here, cannot equal 0. So I'm going to subtract the negative 3 over. So I'll have 2x cannot equal negative 3. And I have x cannot equal negative 3 divided by 2. If I divide 2 from both sides. Okay? And it's going to be the exact same thing for this guy. 2x minus 3 cannot equal to 0. So 2x cannot equal to 3. And if I divide the 2 from both sides, x cannot equal 3 over 2. Okay? So final answer here, we have x minus 3 over 2 times 2x minus 3 with the restrictions of x cannot equal negative 5, x cannot equal negative 3 over 2, and x cannot equal positive 3 over 2. Okay. All right, so here are the steps then to multiply rational expressions. So first, you're going to identify the types of factoring needed, if applicable, to the numerators and denominators. Okay, once you've identified the types of factoring, then you go ahead and factor. Okay, once you've factored, you can slash away. Okay, and then you can slash away right away even when you're multiplying, because factors multiply across the numerators and denominators, so it's just like you have one big fraction that is being smushed together with 2, right? Okay, so last thing, state restrictions. Okay, for all divided factors, even canceled ones. Okay, so basically the ones that are in the denominators. Okay, so let's now move along to division. So let's recall with division, whenever you're dividing fractions, so dividing fractions, the process for that is you multiply by the reciprocal. Okay, so meaning here, we have 2 over 5, but instead of dividing by 18 over 25, this will be the same thing as if I multiplied by the reciprocal, which is just like the flipped version of a fraction. Instead of 18 over 25, it'll be 25 over 18. Okay, so now it just becomes a question like before with multiplication. So I'm going to show you again with the simplification with the factors. So 2 over 5 can't really do anything there. 25 I can turn into 5 times 5. And 18 is 2 times 9, or 2 times 3 times 3. And if I cancel off what's common, 2 and 2, 5 and 5, I'm left with 5 over 9. Okay, so that is my final answer for the quotient of dividing those two fractions together. Okay, so now let's take this as an example for our rational expressions with polynomials. So we have 30 over 2x plus 12 divided by 35 over x squared minus 36. So just like I was saying before, we're going to change this into a multiplication by multiplying by the reciprocal. So 30 over 2x plus 12 is the same thing as multiplying by the reciprocal. So x squared minus 36 over 35. Okay? So now, let's identify some factoring. 30, can't factor that. 2x plus 12, let's factor that into, that's a GCF that we'll do. X squared minus 36, that's a difference of squares. Okay, so now that we've identified the factoring, let's go and factor. So we have 30 over 2, pull the 2 out, that's the GCF, x plus 6 times difference of squares. We're going to have x plus 6, x minus 6, all over 35. Okay, now time to slash away. So x plus 6 goes. Okay, and now we also have these numbers here. So we have 30, we have 2, and we have 35. Let's simplify that. I see here with 30 and 2 that I can simplify that. 30 divided by 2 is just 15. So I'm just going to put 15 at the top instead. Okay, 15 at the top. I still have an x minus 6. And I'm left with the 35 at the bottom. Now, 15 and 35, those can still reduce. I'm going to divide top and bottom by 5. Okay, and I get 3x minus 6 over 7, and that's the final answer. Okay, now in terms of our restrictions, looking at our denominator, so we come back over to this original question. Okay, we see here that 2x plus 12, that's a denominator, so we can't let that denominator be 0, so that we factored over here, so that we can take a restriction. That's going to be x cannot equal to negative 6. Okay, that's straightforward. Now, here's where the restrictions are a little bit different. It's only for dividing. Okay, for when you're dividing rational expressions, do you agree that we're dividing this term right here, 35 over x squared minus 36? Because that's an expression that we're dividing by, this whole thing cannot equal to 0. Okay? So basically what I'm trying to say there is anything that's in the top or the bottom, okay? So either 35 or the x squared minus 36 cannot be 0 in this case because we're dividing by that entire fraction, okay? 35 won't pose a problem for us, okay? But x squared minus 36 will in terms of a restriction, and we factored that right over here, okay? So from there, we're also going to get restrictions. So from there, we see that x cannot equal 6 or x cannot equal negative 6 as well. Okay, so there are three, actually, this is the same restriction over here. So in the end, I can just say that my x cannot equal to plus or minus 6. Okay, if that was a little bit confusing for you, don't worry, come and see me and I'll talk through with you about that again. But we'll be going through some more examples just in a minute here, and hopefully you'll understand the idea about restrictions with division. Okay, so let's look at another example. Okay, so here we have division of two fractions, two rational expressions. So let's identify some factoring first. Actually, no, before that, let's actually flip our expressions, okay? Because we're dividing. So we're going to do x squared minus 2x minus 8 over 3x plus 5. And instead of division, we're going to multiply by 3x squared plus 8x plus 5 all over 2x plus 4. Okay? Now we can identify some factoring. So at the top here, x squared minus 2x minus 8, this is a simple trinomial. 3x plus 5, we can't factor that. 3x squared plus 8x plus 5, that's a complex trinomial. And then 2x plus 4, that's going to be a GCF. Okay? So let's go through and factor. Okay, I'm going to do some side work over here. So for the first one there, I'm going to call this number 1. Okay, the side work we're going to do here, we need two numbers which add up to give us negative 2, and the same two numbers multiplying to give us negative 8. So if you think crunch those numbers in, you're going to have negative 4 and positive 2. Okay, so because it's a simple trinomial, I can just plop those factors right in. So I'm going to have x minus 4 and x plus 2. Okay, over 3x plus 5. All right, and now I have my complex trinomial. Let's do a little bit more side work. Okay, I'm going to call this number 2. Over here, number 2. So we have 3x squared. We need 3x squared plus 8x plus 5. We need two numbers which add to give us 8 in the middle, and those same two numbers to give us 3 times 15, which is, 3 times 5, which is 15. Okay? And those two numbers are 3 and 5. 3 and 5. Okay? So in order to factor our complex trinomials, we need to rewrite. So 3x squared plus, instead of 8x, we're going to break down our middle term of 8x into plus 3x plus 5x, those two numbers we just found, okay, plus 5. Then we factor by grouping. So we have 3x here, x plus 1, plus, pulling out a 5, x plus 1, and we see that we have a common factor of x plus 1, so we get x plus 1, 3x plus 5. Okay, so that's how our complex trinomial factors. So now let's bring this back into our question. So now over here, on the top, instead of that complex trinomial, we're going to have x plus 1 and 3x plus 5. Okay, and at the bottom, we now have a GCF that we need to do, so we'll pull out the 2, and we have x plus 2. Great, so everything is now factored. I'm going to start slashing off. So x plus 2 goes, and 3x plus 5, 3x plus 5. And that's all there is. So what's left over? X minus 4, x plus 1 over 2. Okay? And that's it. That's your final answer. So now let's look at restrictions. Okay? So like I said, we're dividing this, so we're definitely going to need a restriction there. Okay? And because we're dividing this whole term, we're going to need a restriction for both the top and the bottom here. Okay? So let's start with the 3x plus 5. 3x plus 5 cannot equal to 0. So 3x cannot equal to negative 5. So if I divide 3 off, x cannot equal negative 5 over 3. Okay? So that's one of my restrictions. Okay? 2x plus 4, that got factored down here, right? So that is easy to tell what our restriction is. X cannot equal negative 2. Okay, and also our complex trinomial, which we factored here. Okay, this one, x cannot equal negative 1. And if we notice, this is the same factor as we had over here, so we don't need to do that restriction again. So in the end, there's 3. There's x cannot equal to negative 1, negative 2, and negative 5 over 3. Okay, so here's your final answer. Okay, so that's dividing. Let's go through the steps. So, steps to divide. Okay, we're going to flip the dividing rational expression, which is basically your second fraction. Okay? And then change the operation to a multiplication. Okay? And then you just proceed with multiplication, as was described before the division. Okay? So that's for multiplying and dividing. Let's go on now to adding and subtracting.